Hello and welcome to MOS Live, everyone. Today we're talking with Museum of Science educator all about plant powers. My name is Emily, my pronouns are she, her, and I'll be keeping an eye out for all of your observations and questions today. Thank you for those of you who are tuning in on Facebook or YouTube, but please note that we are not able to share your comments with our educators from those platforms at this time. For everyone here on Zoom, just press the Q&A button at the bottom of your screen to submit your questions or observations. Don't forget to include your name and age if you'd like a shout out. If you'd like to see captions, you can click on the closed captions button at the bottom of your screen and select show captions. I would now like to invite our educator to come on screen, introduce themselves, and we'll get started.
Thank you, Emily. Hi, scientists. It's Sue again with our Plant Powers Science and Action presentation at 1 o'clock today. And my pronouns are she and her. And I just want to mention that today we're going to do a lot of observing, predicting, asking questions about a couple of fun scientific investigations that reveal just a few of the plant kingdom's amazing powers. So our first investigation, let's get right into it, has to do with seeds. So I have some bean seeds right here in my hand, and we're going to look a little more closely at them, these little packets of plant potential that don't even quite look alive at this point. Now, scientists, I have a question for you right off the bat. What will these seeds need to get started into the process of becoming plants? And I will wait while you put in your answers.
All right, our first couple of answers: nutrients, water and sun, soil, water and sun, sunlight, CO2. I think that covers it.
Terrific, you guys, you covered it all. All of those things are really important to the process of plants growing, but I'll tell you what the number one thing is, just to get those seeds started, it is water. So without water, none of these processes can happen. First, the seed has to soak up water and get going. So I am going to describe a little experiment I've done in part 1 and part 2 to do with sprouting seeds. And we have a couple of questions based on some observations that we'll have for you. So I have this glass right here, and in it, I've weighed out about 4 ounces of bean seeds. You can use any bean seeds from the grocery store for this type of thing. What I have in here are navy bean seeds, and this is exactly 4 ounces. And then I added exactly 4 ounces by weight of water. If you're doing things like this, it's good to keep the measurements consistent. So not volume, if you've already used a weight. So weight of seed, weight of water. A little kitchen scale is very handy for this. So I added 4 ounces of water, and I want to ask you the question: how long do you think it would have taken these dry seeds to actually absorb their weight in water? Let me give you some guesses. 1 hour, 3 hours, 6 hours, 9 hours, more, less?
Maybe 1 hour or 9 hours even, 8 hours, 4 hours. We're all across the board here.
Everybody's all across the board. It is kind of hard to know because that's a process when we're sprouting seeds we don't often get a chance to see. So I'm going to show you one that I set up the other day and give you an idea of how plant seeds actually absorb water and how long it takes. So let me put this up. So here's the start where we just had the dry beans, and then I added 4 ounces of water. All of those 4 ounces of water were absorbed in about 3 hours. And you can see how much those seeds expanded. But then I left it a little longer after adding 4 more ounces of water, in fact, double the amount of water. And then overnight, you can see that the beans have pretty much expanded a little bit more, but not as dramatically as they did in that first 3 hours. Now that makes a lot of sense Because water can be a really precious resource for plants. In many places, water only comes at certain times of the year and for a very short period, for example, places like deserts. So seeds have to be able to exploit that water as quickly as possible to get going. So they absorb that water very quickly, the starches inside the seeds. And then after that, even more water, so maybe double their weight in water, but very, very slowly, because once they've got that first big boost of water, they're probably ready to go, which is pretty cool. Now, once we know this about seeds, that leads me to part 2 of our investigation, which actually reveals something interesting about what happens to the seeds as they soak up the water. So I'm going to ask Emily to share her first slide. We're going to look at the materials for this experiment, and then we'll dive in. So you can take a picture here if you like, so you will have the materials for this experiment later on if you want to give it a try yourselves. Okay, Emily, I think probably folks have taken their picture. Awesome. So here's how I use the ingredients. What I had was one of these lunchbox size cartons. In this case, it's water. It could be an empty juice carton, could be an empty little milk carton. I love the ones with the cap because this just makes the experiment a little easier, but you'll be able to do it even without a capped carton. So basically what you'll be doing is filling this with seeds. Emily, I'm going to have you show the next slide. So you'll fill it with beans right to the tippity top. If you end up using a carton that you have to open from the top to fill, what you should do is to staple it closed after you've filled it to the tippity top with beans and the tippity top with water. Seal it nice and tight. Now you can see, and maybe you would have predicted that because of the way the seeds expanded in our first part of this experiment, that the carton after about an hour is starting to look a little bit bulgy. So Emily, you can unshare, and I have a question for you all. What do you think is going to happen to that carton by the time we hit the 3-hour mark and maybe longer?
Okay, we have some guesses. The carton will explode. It'll start to tear. Kaboom!
All good predictions. So I think you're ready to see what happened. I have one that I set up here a little earlier. So here's one. All right, you can see up at the top, beans. Off to the side, beans. So obviously the weak spots were where the seams were on this. But this gives us a perfect example of how amazing these seeds are. As they fill with water, not only do they expand, but they keep their integrity, and they can develop enough hydraulic pressure, water pressure, to actually burst things apart. So these seeds are able to generate a lot of force in the process of soaking up all that water, which is pretty awesome. So is everybody ready now for investigation number 2, where we see an easy way to observe seeds once they've sprouted and they begin to grow into plants and learn a little bit more about how they orient to their world? So I'd like Emily to put up another slide. This is the materials list for this experiment. We call it Baggy Gardens, and you can take a picture of that. And then I'll show you one that I've already set up. Emily, anytime. Thank you. All right, so here's one that's been set up and is running. So here's basically what we did. We had a small Ziploc sort of bag, took up one little sheet, one of the skinny sheets of paper towels, and folded it in half, slipped it inside the plastic bag. And then you can see I've stapled a line of staples across the top. Now that actually acts as a little shelf for the beans. So I put my bean seeds, and it's good to use big seeds because obviously little ones might slip down in between that little shelf of staples. And maybe 2, 3, 4, 5, up to 5 beans across. And I used one of these little plastic sign holders to use a binder clip to clip the bag to the sign holder. And I like the baggies that have the little tab in back because I know the binder clip will hold the tab. And once we've set this up, I pour a little bit of water in here. You notice I've labeled it as well, so I know the date that I started it with. You want to use your Sharpie marker for that. And I put a little pool of water that touches the edge of the paper towel, which will slurp it right up to the seeds and moisten them. And eventually those seeds are going to get going. Now I'm going to tilt my screen back a little bit so we can see the actual bean plant that's going there. All right. Now, a fun thing about these is you can observe the entire growth pattern of the bean as it starts, using this sort of as a little transparent viewing area. I like these sign holders because you can move them around. If it turns out you don't have really bright areas in your home, you can move it around to follow the light as the plant develops. You can also tape them to your windows. You'll need a lot of tape. Mine tend to fall off my windows, just so you know. That's why I like using the sign holders. Now, some investigations you can do with this, aside from trying to figure out whether the roots will start first or the plant, where they're going to go, what directions, is you can mess around with them a little bit. So here's another one that I messed with. All right, and we have a few more seeds that sprouted successfully in this one. But basically, after it was growing for a couple of days, kind of straight up and down the way the other one was, I tilted it a little bit because I wanted to see what would happen to the roots and to the shoots. Because you probably already know that roots and shoots orient to their environment. Roots will try and find their way down to the earth. They can actually orient to gravity. And the shoots are going to orient against gravity and towards light. Now, it's something called Stabilists, where a little calcium protein mixture globule things that are stuck onto the surfaces of the roots that actually mechanically stimulate the plant to realize that it's going down, and it generates some hormones in that direction. Meanwhile, the shoot will go up. Now, the minute I turned it a little bit, tilted it, the roots started to reorient to gravity. So the little marks I have on here are where the roots were to start with. You may have noticed they bent a little bit and start heading down the other way, so that they're lined up a little bit more with gravity. Same with the shoots. So you can play around with those a little bit and see if you can discover these orientations to light and to gravity. And these, by the way, scientific word, are called phototropisms. And plants rely on them to grow and thrive out in the real world. Now, does anybody have any questions at this point? And then we'll move on to an investigation I have for you that you can try at home. I encourage you to try all of these experiments at home, but this one in particular, because this final one, I would really like you to change a few things about the experiment and then report back on it.
We don't have any questions yet.
Okay, awesome. So it means I'm going to move on to that last experiment that I'd like you to do and try adapt it at home. It's a deeper dive into plants' ability to find their way towards light. As always, we're going to have a material slide first that I'll ask Emily to share. Okay, I call it running to the light. Awesome. Thank you so much. So I have another slide actually for Emily to share. Actually, maybe the next couple we'll just leave up and I'll keep talking. That sounds good. One after this. Terrific. So the first slide you see there is a big box that I got and opened it up. Now, when you look at this box and hold it up to the light, I noticed a few spots where the light was shining through. And since I wanted to control light in this experiment, I took a little tape and covered up the places where I could see light leaking in. And then in the second photograph, I've taken extra cardboard and I made a little chamber in one corner of that box, taping it in place. And you notice where the arrows are? They're little windows. So I cut a little window in the inner chamber and a little window in the outside of the box. And finally, in that little inner chamber, you see there's a pot. So I potted up some bean seeds. And for things where you're sprouting seeds, you definitely want not to use bagged beans from the grocery store. You want to get a seed packet from a seed company, because you never know how long your beans in the grocery store have been sitting around. They may not be good for sprouting. Ones from a seed packet are going to be more reliable. So I got a little pot of seeds inside the inner chamber. And then the final thing was I set it up with a dark towel, nice thick one, folded it over twice to cover up the top in case there'd be any light leaking in, folded the box closed, and put a brick on top just to make sure everything kind of stayed in place. And I toted it out to my backyard where I knew it would be in the sun, which is going to be coming in that little window on the outside. So anybody who would like to make a prediction about what those seeds would do when they sprout inside that dark little box?
We're a little unsure.
That's okay. This is the fun part about science, because we do these investigations or experiments so that we can find out what's going to happen. So I think we're probably ready for Emily to share that final slide that I took this morning when I opened up the box, so you can see what happened. 2 bean seeds have sprouted. One, which may have come up a little earlier, crawled out through that first little window and was on its way to the second window. However, there was another little plant in the corner, maybe who started a little later, that's still stuck in its corner. So the plant was able to find its way through that first window, was on its way, sensing light to get out to the light. And these are pole beans, by the way, so they get big really fast, which is kind of fun when you're doing this kind of experiment. You get results a little bit quickly. So I'll ask Emily to stop sharing, and I'll suggest some ways that you might adapt this experiment. But first, let's look a little more closely at the plant that I took out of that little box this morning. So this is the one that was on its way to the second window. Right down here, you notice what we call the seed leaves. These are basically the 2 halves of the bean that morphed into leaves, and then the first true leaves a short distance away. Now, pole beans have a lot of distance between their little groups of leaves. The places where the leaves are found are called nodes. The stem in between is called internode. And what you'll notice when you have plants in the darkness is the distances between the leaves, the nodes, are actually elongated. Now, the way plants find light is they have special pigments in their skin, so to speak, that actually in the cells of the skin that pick up the light where it is, where it isn't. On the side of a stem where there's less light, hormones gather, and it causes each of the cells to elongate. So this side gets longer, and that bends the stem in the opposite direction towards where the light is. That is how they will find their way. Now let's look at this other little one right here. You'll notice that it's very, very light green. Until plants find the light, they can't begin photosynthesis. So they have a lot of energy to start in the seed. That starch that's stored in the seed acts as a nutrient, almost like the yolk of an egg, to keep the plant going until it finds light. But if it doesn't find it right away, another characteristic of plants that have been in the dark is they will be very, very pale. So here's how you can modify this experiment. You noticed we had our plant in one little chamber, but that was a big box. So maybe you would take a lot of extra cardboard and make an actual maze. Lots of little walls with lots of little windows that the plant is going to have to work its way through to get to that outside window and the light. So that might be an experiment you can try at home. Add some extra walls and windows. See how far your plant will go in its search for light. If you try any of the other experiments, I'd like to hear about it too, but I'd like to thank you for coming to Science in Action Plant Powers today, and have a great afternoon.
Thank you so much, Sue. We did have a question come in. Um, One is, are they called bean stalks, the plant that you're using?
Beanstalks, absolutely. Those pole beans are referred to as beanstalks. And when they grow to their full size, they can get quite tall, maybe up to 8 feet or more. And they're definitely stalks at that point. So, yes, a very good everyday name for them.
And are there other seeds that we could use for this experiment?
Yes. Another interesting seed to try because it's a big seed is corn. Now, corn grows very differently. I won't give away the surprise too much, but beans are dicots, which means they have two seed leaves. Corn grows very differently. It's a monocot. So if you'd like to try corn seeds, see what their little shoots look like and see how different they are from what beans will do.
And you mentioned we have to buy actual seeds from a store rather than maybe the beans you would find in the supermarket. Where can we find those sorts of seeds?
You can find them in a lot of catalogs or a garden center near you. They have them in seed racks. Sometimes it depends on the time of the year because they change what they have seasonally. So seeds tend to be more available at garden centers in the spring when people are doing a lot of seed planting. So more reliably are catalogs and online ordering. Really good local company is Johnny's Seeds, JOHNNY, and they are a Maine company and they have seeds pretty much all year long. That's where I got my bean seeds.
Awesome. Thank you so much. I think those are all of our questions. So I'll just have you say goodbye.
Goodbye. Thanks for coming.
Thank you. All right. And thanks to all of you for tuning in today. You were excellent scientists with great predictions and questions. To check out more programs, you can visit the website mos.org/MOS at home or follow us on social media. And if you do try this experiment at home, share it with us. Take a picture of your plant maze and tag us in a post using hashtag MOS at home. And if you've enjoyed today's presentation, please visit the website on the screen to support MOS at home. Thank you, everyone. Enjoy the rest of your day, and we'll see you next time.